Hello students. Today we are going to find another way to find a solution of a system of equations. We have learned how to find the solutions when you're graphing. Sometimes graphing does not work and it's hard to tell where the two lines cross. In that case, we want to make sure we have other ways of learning how to solve your systems of equations. So I'm on page 97 in your packet. So I'm skipping Unit 8 for right now. Okay, so solving systems of equations by substitution. First, we were given two systems of equations, here and here. We want to ask ourselves, is there a variable isolated? Yes or no? If the answer is yes, then we want to use that and substitute it into the second equation. So here's your two equations. This one is isolated, so we take the 5x plus 7 right here, and we're going to plug that in for y in the second equation right there for where the y is right there. So it's going to be this equation, but this will be substituted for the y. So there won't be any y in your equation. Then you'll have just one variable, and then we can solve for x. So we put the 5x plus 7 in for that y right there. That's where this equation comes from. And then we solve for x. Here we go, 2x plus 15x plus 21 is negative 5. Combine like terms. Negative 2x plus 15x is 13x equals, and we did minus 21 is negative 26. Divide by 13, and x is negative 2. Now, once we have one variable solved for, we can solve for the other one. So we put negative 2 back in for our x value, and we solve for y, because we know y equals 5x plus 7. If we put negative 2 in there, y equals 5 times negative 2 plus 7, and y equals negative 3. So we write our solution as a coordinate point or as an ordered pair, x comma y. So the solution here is at negative 2, negative 3. Okay? So here we're going to do some more practice. Use substitution to solve. Give the solution as a coordinate or as an ordered pair. So when you look at these two, which variable is isolated? And the answer is y, because it's y equals 6. When you get just one number, it usually makes it really easy. So all we have to do is take that 6, and we're substituting it for y in our second equation and solve for x. So we get 6 equals negative 7x minus 22. Okay, I'm going to use the reflexive property because I like my variable on the left side, and I'm going to rewrite it so this is on the left and this is on the right. So I get negative 7x minus 22 equals 6. Then I'm going to add 22, negative 7x equals 28, divide by negative 7, and x equals negative 4. Now, generally, you have to plug negative 4 back in to find out what your y is. However, we see that our y is equal to 6. So our ordered pair would be negative 4, because you always list your x first, and then 6 for your y value. And there's your solution for number 1. Okay? Let's go on to number 2. You look at here and you say, which one of those is isolated? And being it says x equals 1, we know that x is isolated. So I'm going to substitute this 1 back in to the second equation. So I get negative 1 minus 3y equals negative 19. Then I'm going to add 1 to both sides because, again, I'm going to solve for y. Negative 3y, again, don't forget the minus sign becomes negative here, equals negative 18. Divide by negative 3, and y equals 6. Okay? So when we put our ordered pair, generally we would have to plug this back in, but it's really nice here because it tells you x equals 1. So our ordered pair would be x is 1, and y is 6. So there's our ordered pair for number 2. Okay? We're having so much fun. Let's go on to number 3. We have y equals negative 4x, and then we have negative 4x plus 5y equals negative 24. Now, which one is solved? We have a y equals, so that's already solved for y. So we're going to put the negative 4x in to the second equation for that y. So again, when you're substituting something back in, you get rid of a variable. Okay, so when I do that, I'm going to write the second equation, negative 4x plus 5, and then I substitute in parentheses the negative 4x from the top for your y value on the bottom, equals negative 24. Now, all I'm going to do is substitute or solve for x. Let me move this just a minute so that you can see just a little bit better. All right, so negative 4x plus 5 times that, negative 4x, and this will be minus 20x equals negative 24. Combine those, negative 24x equals negative 24, divide by negative 24, x equals 1. Okay, so now we have to plug 1 back into either of these. Now for me, it looks like the top one would be easier to plug in your 1 value. I could put 1 in for x here, or I could put it in here. And it's easier to solve for it right there. So if we say y equals negative 4 times 1, y equals negative 4. So once we have that, we can put it in our ordered pair form so that our solution will be 1, comma, trying to fix the lighting a little bit here. Okay, that's a little better. So ordered pair form again would be 1, comma, negative 4. And I could check it by putting 1, negative 4, and making sure it's a solution algebraically for both of those equations. So there's how you do number 3. Okay, you can stop the video now and see if you can go on. I'm going to go ahead and continue on and do number 4. Okay, so which variable is isolated? Well, they're both y equals. So I'm going to go ahead and take this first one and substitute it into the second one. So I'm going to put negative 8x minus 11. See, I put all that in for the y equals x minus 2. Okay, and then we just solve for x. I'm going to go minus x here, minus x. So I get negative 9x minus 11 equals negative 2. Then I'm going to add 11 here, and I get negative 9x equals 9. Divide by negative 9. So I get x equals negative 1. Now, I've got to substitute it back into one of my original equations to figure out what y is. This one looks much easier to substitute in, so I could say y equals negative 1 minus 2, y equals negative 3. So our solution is going to be negative 1, comma, negative 3. And if we wanted to plug it back in there, we could see that both of those would work for both of these and makes the equation true. Okay? All right, so I believe the next page is 98. But that gives you a good foundation of how to do it. And your homework should be doing page 98. And we'll talk about whether you need to do 99 as well. So there's 98. And good luck, students. You rock.